Hello everyone, in this video I will focus on an object which is constrained to move in a plane. We will define the position, displacement, velocity and acceleration of an object moving in a plane. The position of an object is defined with respect to the origin of the coordinate system. Thus, the position of an object is a vector from the origin to the point where the object is currently located. Suppose that the origin of the coordinate system is O and the object is currently located at point P having coordinates x and y. The position vector of the object will be a vector from the origin O to the point P. The x component of the vector will be x and the y component of the position vector will be y. The position vector can be written as r equals to xi hat plus yj hat. Now suppose that at time t1 the object is located at point P having coordinates x1, y1 and at time t2 the object is found at point Q having coordinates x2 and y2. The displacement of the object will be a vector from point P to point Q. Thus, this is denoted by delta r. The x component of the displacement is delta x, which is equal to x2 minus x1, and y component of the displacement is delta y, which is equal to y2 minus y1. Thus, we can write displacement as a vector delta r is equal to r2 minus r1. This is equal to x2 minus x1 I hat plus y2 minus y1 j hat, and this is equal to delta xi plus delta yj. Before moving forward, we will take an example. Suppose that an object is moving in a plane and its coordinates is changing position with respect to the equation x is equal to minus 0.31 t square plus 7.2 t plus 28 and y is equal to 0.22 t square minus 9.1 t plus 30. We are required to find the coordinates of the point at t is equal to 5 seconds and t2 is equal to 15 seconds. Now at t1 is equal to 5 seconds, the coordinates of the object are x1 is equal to minus 0.315 square plus 7.2 times 5 plus 28. This comes out to be 56.25 meters. Similarly, y1 is equal to 0.225 square minus 9.15 plus 30. This comes out to be minus 10 meter. Therefore, the position vector of the object r1 is equal to 56.25 I minus 10j meters. Similarly, at t2 is equal to 15 seconds, x2 is equal to minus 0.3115 square plus 7.2 times 15 plus 28. This comes out to be 66.25 meters. And y2 is equal to 0.2215 square minus 9.1 times 15 plus 30. This comes out to be minus 57 meters. Therefore, R2 is equal to 66.25 I hat minus 57 j meters. The displacement is equal to R2 minus R1. This is equal to 66.25 I hat minus 57 j minus 56.25 I hat minus 10j. Therefore, displacement is equal to 10 I minus 47 j meters. We can plot the coordinates of the object with respect to each other. So in this x-axis is x coordinate and in the y-axis we have y coordinate. The object is changing position according to this curve. The r1 vector is this one, the r2 vector is this one, and displacement vector is from r1 to r2. Now that we have defined position and displacement of an object, we can define average velocity and instantaneous velocity as well. The average velocity is equal to displacement over time interval. This is equal to delta r by delta t. This can be written in terms of its components as delta xi plus delta yj divided by delta t, and this is equal to delta x by delta ti plus delta y by delta tj. Now delta x by delta t is x component of average velocity and delta y by delta t is y component of average velocity. Therefore, V average is equal to Vx average I plus Vy average j. Similarly, instantaneous velocity is defined as V equal to delta r by delta t when delta t tends to 0. This is equal to dr by dt. dr we can write it as dxi plus dyj. Therefore, V is equal to dxi plus dyj by dt, and this can be written as dx by dt I plus dy by dt j. Now dx by dt is x component of instantaneous velocity and dy by dt is y component of instantaneous velocity. Therefore, v is equal to vxi plus vyj. Now let us go back to the previous example where we have calculated the displacement and position vector of an object moving in a plane at times t1 is equal to 5 seconds and t2 is equal to 15 seconds. Now we will determine its average velocity between time 5 seconds and 15 seconds and instantaneous velocity at time 10 seconds. Now we know that average velocity is equal to V average. This is equal to delta R by delta T. Now delta R we have already obtained, and that was equal to 10I minus 47J, and delta T is equal to 15 minus 5, and this is equal to 10. Therefore, V average is equal to I minus 4.7J. Now we will calculate instantaneous velocity. We know that instantaneous velocity V is equal to dx by dt I plus dy by dt j. Dx by dt is equal to d by dt of minus 0.31 t square plus 7.2 t plus 28. Now d by dt of minus 0.31 t square is minus 0.62 t, and d by dt of 7.2 t is 7.2, and d by dt of 28 is 0. Therefore, dx by dt is equal to minus 0.62 t plus 7.2. Similarly, dy by dt is equal to d by dt of 0.22 t square minus 9.1 t plus 30, and this is equal to 0.44 t minus 9.1. Therefore, instantaneous velocity of the object has the expression v is equal to minus 0.62 t plus 7.2 I plus 0.44 t minus 9.1 j. Putting the value of t is equal to 10 seconds, we get instantaneous velocity as minus 0.62 into 10 plus 7.2 I plus 0.44 into 10 minus 9.1 j, and this comes out to be I minus 4.7 j. Now we will define average acceleration and instantaneous acceleration of an object moving in a plane. The average acceleration of an object moving in a plane, A average, this is equal to delta V by delta T. Delta V we can write in terms of its components. This will be equal to delta Vx I plus delta Vj. Therefore, A average is equal to delta Vx I plus delta Vyj divided by delta T. This means that A average is equal to delta Vx by delta Ti plus delta Vy by delta Tj. Similarly, instantaneous acceleration can be calculated as follows. Instantaneous acceleration is equal to delta V by delta T when delta T tends to 0. This is equal to dV by dt. Writing dV in terms of its component, we can get instantaneous acceleration as dvx by dti plus dvy by dtj. and this is equal to x component of acceleration times I plus y component of acceleration times j. That is, instantaneous acceleration A is equal to axi plus ayj. Now let us go back to the previous example where we have determined the position and displacement of an object moving in a plane with respect to time at t1 is equal to 5 seconds and t2 is equal to 15 seconds. Then we have determined its average velocity and instantaneous velocity. Now we will determine the average acceleration between t1 is equal to 5 seconds and t2 equal to 15 seconds, and then we will find instantaneous acceleration at t equals to 10 seconds. First we will find the average acceleration. The average acceleration A average, this is equal to delta V by delta T, and this is equal to V2 minus V1 divided by delta T. Now delta T is 15 minus 5 and this is equal to 10. We have already determined the expression for V, and that is equal to minus 0.62 T plus 7.2 I plus 0.44 T minus 9.1 J. Therefore, V2 is equal to V at T is equal to 15 seconds. Putting T equal to 15 seconds here, we get V2 equal to minus 0.62 into 15 plus 7.2 I plus 0.44 into 15 minus 9.1 J. This comes out to be minus 2.1 I minus 2.5 J meter per second. Similarly, V1 is equal to V at T is equal to 5 seconds, and this comes out to be minus 0.62 into 5 plus 7.2 J plus minus 0.62 into 5 plus 7.2 I plus 0.44 into 5 minus 9.1 J. This comes out to be 4.1 I minus 6.9 J meter per second. Now delta V is equal to V2 minus V1, and this comes out to be minus 6.2 I plus 4.4 J meter per second. Therefore, average acceleration is equal to minus 6.2 I plus 4.4 J divided by 10, and this is equal to minus 0.62 I plus 0.44 J. Now we will determine instantaneous acceleration. We know that instantaneous acceleration is equal to dvx by dti plus dvy by dtj, where vx and vy are x and y components of velocity. Dvx by dt is equal to d by dt of minus 0.62 t plus 7.2. This is the x component of velocity. The derivative of minus 0.62 t is equal to minus 0.62, and derivative of 7.2 is 0. Therefore, dvx by dt is equal to minus 0.62. Similarly, dvy by dt is equal to d by dt of 0.44 t minus 9.1. This is the y component of velocity. This is equal to 0.44. Therefore, dvy by dt is equal to 0.44. Therefore, instantaneous acceleration is equal to minus 0.62 I plus 0.44 J.